Hello, everyone, and welcome to the North Central Region Water Network's Speed Networking webinar series. The North Central Region Water Network is an extension-led collaboration among land-grant universities in 12 upper Midwestern states. I'm Rebecca Power, and I will be your moderator for the day. Normally, we have three presenters, but today we are featuring Kansas's long history of irrigation policy and technology and what we might be able to learn from it across the North Central region. Our presenter today is Dr. Danny Rogers from Kansas State University. All of our webinars are archived on the North Central Region Water Network website at northcentralwater.org and learn.eextension.org. We'll be listening to Dr. Rogers for the first part of our time today, and then we will ask, while you're listening, if you could please submit questions to Dr. Rogers through the chat box, which should be in the lower left-hand portion of your screen, and we'll get to those questions once he's finished presenting. If we were able to, we'll depending on the number of people we have today, we might ask you to try to also speak using the talk button, which is in the upper left-hand portion of your screen, and we'll help you with that if we need to when we get to that point. So with that, I'm going to go ahead and introduce Dr. Rogers. He is a Kansas State native, raised on a Northeast Kansas farm, and has his PhD from Oklahoma State, licensed professional engineer, and doing a lot of great work in Kansas, an ASABE fellow, and he'll tell you a little bit more about everything that he's doing related to irrigation policy and technology. So with that, welcome, Danny Rogers.
Well, thank you very much. I appreciate the opportunity and the past seminars as well. I'm going to try to, each of our states are a little bit different in terms of how we're set up, and as far as my position, I'm a extension specialist and ag engineer, primarily focused on irrigation. I service the county agents, which are organized by county, but in the recent years we've had ability to have counties join together and make districts as a way to let the agents specialize a little bit more. So in those faded green areas you see on that slide, those are counties that are joined together to form a district. We're also combined together in terms of extension and research together, and the blue dots and open circles are experiment farm stations that we maintain throughout the state for the different climatic zones and soil conditions across the state. The dark blue ones, Colby, Garden City, are our main irrigation stations, although there's irrigation at Tribune and the Topeka-Rossville units as well as Scandia. Here's how, these are the points of diversions for irrigation in Kansas, so you can see where my clientele groups are. They're concentrated in the west and along the river valleys in the east of the Republican and Kansas River Valley. And so it looks like, so if you look at it just from a irrigated crop stance, about 15% of our cropland in Kansas is irrigated, symbolized by these red dots. Again, you see they're focused in southwest and south central Kansas. As far as the types of activities, our primary focus in irrigation water management and trying to more now we do more work in doing decision support software, such as the CanSched is the ET-based scheduling program. But we also work more now on the total water budget, where we try to look at the effect of residues on crop evaporation, precipitation capture, and of course how well the crops respond to those different situations. We also do a lot of work in systems and of course irrigation pumping plant efficiency. Parallel or complementary to that, or actually our work is based upon the research which cover more or less the same things with a little more emphasis on the agronomic studies than what I do as an extension guy, as an engineer. But you kind of see some of the things we've been doing over the year. Kansas is a really good place to do irrigation work because of we go from semi-arid to humid, and so our precipitation ranges from 15 to about 45 across the state. But at those red arrows, or red stars rather, you can see that no matter where we are in Kansas, even though we get ample rainfall in the southeast corner of the state, we still have yield limiting periods of the summer growing season where crop water stress will limit yields. And so if we would probably do more irrigation across the state if we had more irrigation water supplies available to us. From a irrigation standpoint, the net irrigation requirements for, this is for corn, although it's only maybe slightly less for some of our other summer grown crops. It ranges from about 14 inches in the west to 5 or 6 in the east. I use this as a poster child when I talk to groups about the need for irrigation. It's a study that shows that in like 91, it's a relatively old study, but it illustrates the point very well. In 1991, it was a dry summer, no irrigation at the treatment there at Scandia, which is at about the average precip for our state. We had no, basically no yield. And a single irrigation then at Tassel, a stage of growth for corn, resulted in a 120 bushel yield increase. I also use this slide to illustrate the importance that we shouldn't be doing it just by calendar or stage of growth. This was an early study that shows where we're using soil depletion as a criteria. We actually got better yields, and over the long period of time actually used less water than using the stage of growth type methodology that was being employed at that time. I already mentioned we only have about 15% of our cropland irrigated. That's about 3 million acres irrigated. Most of it is center pivot irrigated now. Corn's our most common crop. In fact, we actually set a record for acreage in 2013 for irrigated corn. The other major crops are wheat, alfalfa, soybeans, and grain sorghum. Most of our water supply comes from the High Plains Aquifer. The most famous one of that is, of course, the Ogallala, which is depicted in blue here. An important aquifer in south central Kansas is the Great Bend Prairie Aquifer, and the Equus Beds is an aquifer around the Wichita area. It's the only aquifer in the state that has more municipal use, or has as much municipal use out of it as does the irrigation. About 85 to 90% of our diverted water goes to agriculture, which is primarily irrigation. Kansas has a long history of irrigation development. Started in the 1890s in southwest Kansas along the Ark River. Surface irrigation, there's still 7 irrigation districts, surface irrigation districts in southwest Kansas. They don't divert water every year. And the last major project was built in the 1940s, which is in the Kansas Bostwick area of north central Kansas, where Scandia is located. There was actually early attempts to do groundwater irrigation in western Kansas, and in fact, K-State had experiments at both Garden City and Colby using deep well turbines from wells, not deep well turbines, from 1907 to 1920. And here's the pictures of the early two of the wells from Colby. They would pump into a reservoir that's in the lower left there, and then from there they would divert that water into open canals, laterals at the top of the field, and use siphon tubes to divert that water to the fields. And contrary to popular rumors around here, I was not part of that project. I think that's me over here floundering if I was actually there. But it turns out the best use of the irrigation water was making that lagoon for kids to play in. We actually abandoned all those irrigation projects as being uneconomical in the 1920s. And the next big act was 1945, where it kicked off, it sounds like an act to prevent water development, but it's actually an act to encourage water development. and it did prompt a rapid development of irrigation in western Kansas. And it sets the criteria to allow the development of water rights. The water in Kansas belongs to the people of the state, but you can put it to beneficial use by following these appropriation guidelines. And one important aspect of that act was that there could be no impairment from developing new water supplies. And so that was the protective aspect of it that prompted a lot of development. However, the act itself wasn't really what kicked off irrigation. It was all the other technology advances, the engines and gearheads and deep well turbine pumps that were came into availability at that time. And a lot of that technology was developed out of World War II, as well as aluminum, which then became gated irrigation pipe. Of course, it didn't hurt to have the Hugoton natural gas field be developed at that time in southwest Kansas, and basically they provided free energy to landowners that wanted to develop irrigation for quite a number of years. Since it was still mostly surface irrigation at that time, they would pump out of the wells into canal systems that would carry them to the fields where they'd be distributed originally by the laterals, pulled laterals, and then eventually converting it to gated pipes as depicted here. Of course, the upshot of all this is that there was a large supply of water available. This is the map of the High Plains Aquifer. The dark blue is very deep aquifers. Some areas it was as much as 800 foot thick. But as we used it, you can see in this slide, you see a lot less dark blue areas now and a lot less green areas. And so we actually have depleted a large portion of that aquifer already, as illustrated by this. West central Kansas in that 3 or 4 county area there has depletion rates of 60% or more. It's kind of the poster child of where what might have happened, what we could happen as we continue to pump from that water. Why is it going? Sorry here, I must have been on the wrong button there. So at about this time then in 1952 was the patent for the center pivot irrigation system was developed, and I've had people tell me that they thought the reason we had overdevelopment was because of the center pivot, but as of 1970 there was only about 345,000 acres of center pivot irrigation in Kansas as compared to almost 2.58 million acres of flood. So irrigation development would have still continued even if the center pivot had not been developed. And just to show the early prototype by Zybeck, who's the patent holder of that, and then the early water drive by Valley, and then some more modern systems. Well, what really though I think was probably that allowed or that resulted in overappropriation of the Ogallala was this amendment in 1957, which softened the rules of the, where we said initially no injury to subsequent users. The first right holder would be protected. This one, according to our Assistant Attorney General in a presentation he made, it softened those standards and allowed us to go from rather than direct impairment to whether or not there was any economic impairment. And when you're pumping out from a deep aquifer and also improving your technology at the same time, the gallons per minute per acre that you needed was steadily decreasing and was more than being capable supplied by the aquifer. But this did allow a lot of development to occur based on that no impairment rule being softened. So then, with that development then, in the late 60s, early 70s, there's recognition that there's a problem developing, but it took until 1978 before we actually had a amendment to the act that required a water right to be used or to be instituted before you could divert water. Up in that point in time, you could still drill a well and divert water even if you didn't, as long as you didn't want to develop a water right. This act also had a clause about development of intensive groundwater control areas, we call them AGUCAs, and we actually have 10 of them still in existence. And the early ones, most of them dealt with putting water meters on and utilizing some other more controls for hotspots, usually associated with municipal supply. Well, if you look at a quick pictorial of irrigation wells or points of diversions, these are all in the state, you can see that there's very little in the 40s and the 50s. We were kicking off strong in the 60s. If we would have thought to institute those controls more quickly, like between the period of 1970 and 1980, we probably would have been in a much better situation right now. But it took until '78 for us to close development in the western part of the state. The development in central Kansas and eastern Kansas has been more or less on a safe yield basis, and so they're in a sustainable area. So I actually say the end of the rapid development stage was in '78, when most of the western Kansas was closed to further development. And '72 was the Groundwater Management District Act that I think was the time that we had official kickoff of where we were going to try to manage our way out of the problem by conserving and increasing efficiency. Of course, in some areas are so over appropriated we'd have to be about 400% efficient, I think. But we now have 5 groundwater management districts formed in the state that cover all the major irrigated areas of western Kansas, south central, and around in the Equus beds. So we're still relatively stable, about 3 million acres of irrigation in the state. But if you look at how it's distributed, we've actually have lost about 10% of our irrigated acres in western Kansas, but it's been offset by gains in south central and eastern Kansas. Most of the water supplies in central and eastern Kansas are fully developed now, so I think we'll see a steady drop of the irrigated acres in the state over the next number of years. Well, I actually joined K-State Research and Extension in 1977 in the Northwest Area Office at Colby. The very next, like 6 months later, there came out the first major study on the High Plains Aquifer that I read anyway, and it's projected a 20-year life on the aquifer. So I thought I made a pretty bad career decision to be an irrigation engineer, since it would only span about 20 years. I tell my bosses that the projected life of the Ogallala is now 50 years, so it's been almost 40 years later and a 50-year lifespan. I said I ought to be getting a big raise over that, but so far it hasn't happened. Undaunted, some of the programs that kicked off at that time were a water project. We called it Water Cup, Water Conservation and Utilization with GMD4, and we were looking at trying to promote the use of irrigation water meters and soil sensors for scheduling. We also kicked off ET-based irrigation scheduling at that time, but it was difficult to accomplish ET-based scheduling at that time. So we were using gypsum blocks on these deep silt loam soils, and they worked very well out in that area. The problems with soil-based irrigation scheduling, particularly at that time, was you had to get them installed, you had to put them in a representative part of the field, and then you had to go out there and read them, and then you had to plot it, and then you had to interpret that into what the schedule was be. And it actually worked very, very well, but it was as soon as I quit putting them in the ground, my cooperators quit using them. As far as ET-based scheduling, we actually still promote that very heavily. The limitations initially was that well, the reason we could start an ET-based scheduling program because when I first went to the office there, we had, for technology for information transfer, was a mimeograph machine. But within a couple years, we actually got a copier, which I thought life was great at that time, and I had a programmable calculator. And so every morning I'd have to put in 4 or 5 strips of these strips into that calculator so we could calculate the ET formula or calculate the ET number, but we'd have to wait until someone manually walked out to the weather station, picked up the data from the site. We'd call out there and get the numbers, and then we'd have, after we calculated it, our distribution method was putting it out on a radio station a couple times a day, and then distributing it via newspapers, which were weeklies at that time. So it's hard to do daily-based irrigation scheduling with the technology available at the time. Of course, even if you had the ET information, you'd have to hand enter that into some kind of chart, so that so here's an example from Freddie Lamb, who's my colleague out at Colby Experiment Station, or the Northwest Research and Extension Center now, and it was like 17 pages of calculations over the course of scheduling, versus in the lower right is a software program, CanSched today, that once you enter the value, will update all your fields. This ET work has been really hard though, because look how much it's aged me trying to get that information out to farmers. We're doing a lot of soil surface irrigation work at the time for furrow advancement, tailwater pits, so forth. And so here's an example of a surge irrigation on the experiment field and one on a demonstration field. Since we only have about 5% flood irrigation now, I can't even take you to a surge valve right now off the top of my head. Of course, we started working on center pivot packages and management. One of our later programs was to evaluate uniformity of center pivot systems, and primarily for our objective was to look at the effects of package wear, package misinstallations, and other things that can go wrong on that. We were using these catch cans we called air gauges that were non-evaporating things, and so I could have stopped after the first test, because this is the first one we did in Finney County. Section A is where you have some variation, but it's still 90% uniform or above, which is the industry standard for sprinkler irrigation. You would also, Section B shows how much water you might apply due to a leak. In this case was a boot at a pivot tower. Section C, though, is one that was kind of interesting, and we've come across this a number of times, where you would have a span package reversal. You have to have larger nozzles as you move out away from the center pivot point. And in this case, span 7 had nozzles around 6, and 6 were on 7. So you had your nozzles, smaller ones on the inside. You can see there was slightly more water application. Of course, it was kind of buried by D, which is the end gun is supposed to ratchet back and forth, but this one is spinning back onto the body. The impact of this, though, might be better illustrated by, again, an early pivot study test that we did in '99. In this case, a lot of these things could be found by comparing just doing a visual inspection and comparing to your sprinkler package spec sheet. In this case, there was a missing drop nozzle at the outer edge of the pivot, and for some reason, 2 nozzles on either side of that missing one were undersized by about a half. The impact on yield would be there was about only about half the water that should have been applied was applied. In that area, they normally put on about 12 inches, and so a conservative estimate of yield response is 10 bushels per inch. So that $200 repair was costing them, 500 plus bushels every year by not having that package up to snuff. Well, in the late 80s, my colleague Freddie Lamb called me up and said, "Hey, what do you think about trying to adapt micro-irrigation to corn production?" And he'd seen some work done in Arizona on cotton trying to fix this out, and so we decided to try to do some subsurface drip irrigation work, and which is using these drip lines that are buried underground between the rows permanently. We use about 16-inch depth on our silt loam soils every other row, and that's what the sketch shows. And then the lower 2 pictures are the plot work study done out at Colby, one of their drip sheds and one of the control panels inside. It's that original drip line that we put in 1989 was replaced. This is the first was replaced last winter, so it went 26 years before we started having some, the nozzles weren't, the emitters weren't clogging, but some of the bonds that were holding the lay flat tube together were starting to break down, and we were getting some splitting problems. And we think there's even better products today, so these systems can be long-lived, which are important to economics. We only have about 1% of our irrigated acres in SDI at the moment, but we do have a couple hot spots of development. For example, in the Equus beds area, for like McPherson County, 16% of their irrigated land is in subsurface drip, almost 6,000 acres in that one county. And then here's a couple pictures of some commercial sites. The lower left would be a automated zone control valve, so they could switch automatically. The other ones are just the installation at the well site. 2002 kind of marked another big legislative action for our state. There's always a concern that expressed concern about you could lose your water right if you didn't use it. So it's official now. You can't, as long as you report non-use, you can't lose your water right. But I think the more important acts of that time were the LEMA, which is a local enhanced management area, and the multi-year flex allocation. In 2011, almost all the state, but eastern Kansas in particular, was in a terrible drought. And we had many eastern Kansas irrigators exceed their water allocation, which is done on an annual basis here at mostly. And so if you have enough violations of your annual allocation, you have an increasing degree of penalties associated with it up to losing your water right. The multi-year flex allocation allows people to move from an annual allocation to a multi-year allocation, normally 5 years. And the LEMA, the local enhanced management area, was also enacted at that time because there were several parties in western Kansas interested in trying to reduce their water consumption to even a greater degree than what was currently in place. But they didn't want to go through the IGUCA because they wouldn't have, once they propose something, it goes to a hearing, and actually the chief engineer then has the final say about what will or will not be instituted. Whereas the LEMA, it's a kind of a voluntary IGUCA. They propose rules. The chief engineer can either accept or reject them, but he can't impose any additional restrictions than what they propose or without their approval. But once they're approved by both parties, then they have the same effect of current law. So that might have been the beginning of a new era here, in that we do have some additional tools in the toolbox. In fact, there's been an even additional one where farmers, a farmer or even a small group of farmers, can use a WCA, which is a water conservation area, and they can make an agreement with the Division of Water Resources chief engineer about how they will. It has to be associated with a reduction of water, but they can have increased flexibility of how they handle the water rather than just the annual allocation process of the Water Appropriation Act. We did have a lot of activity in 2013 where I think there's over 1,000 of them now, multi-year flex plans. We do have one LEMA established. We've had several others attempted to be formed, but not quite, didn't quite get implemented, but still trying to do that. And there's also some more. There's also more stringent enforcement of rules about water meters and overuse and so forth and so on. Well, here's some of the things that we are working on and others are working on. Probably the ones that we work on the most right now is the mobile drip irrigation, which is, I'll show you a picture in just a second. And the thing I'm kind of excited about is probably the arena of plant health sensors in terms of how we might be able to better manage our water resources for irrigation in the future. We also keep trying to improve our decision support software. And we have a number of different packages, but the three related to strictly to managing irrigation water are the crop water allocator, the crop yield predictor, and the CANSCAD. The water allocator and CANSCAD are probably more in common use. The water allocator helps people to make long-term decisions about what crop mix they want to use on a particular land resource base and water supply they have availability. And CANSCAD is a daily ET-based irrigation scheduling program, and we have several versions available, and we're working on a smartphone app too that's been requested. Mobile drip irrigation, even though it's often thought of as a new technology, we actually had trials with this 15 years ago now, but there's a new product line out that are depicted in this orange tubes. These drip micro-irrigation lines are attached directly to the drops on the pivot. The new technology they're trying to incorporate uses some wiring and cables to try to implement or to stabilize where those lines stay. And the idea is to get the water directly to the ground so that the crop canopy is not wetted, and that would improve your irrigation efficiency since that is a major loss point, is wetting the crop canopy. The lines can be custom. For each location, they know what flow rate they need out of that at that site, and so the lines can be cut so you have varying length of lines throughout the field. We actually have a second-year study at the Southwest Research and Extension Center. So they've completed 2 years of work with this, and this year we established 3 on-farm sites, irrigation technology farms, where MDI systems are the centerpiece of the comparison. But they also have soil sensors. The industry has developed a wide variety of soil sensors. And the major advantage of the new instrumentation is you can get the data without having to visit the field. We still have some of the same issues in terms of getting them located in the right spot and interpreting what that means relative to the whole field, but they definitely have some advantages in terms of being able to get a visible product of what's happening at least within that location. But as I said, I think the thing I'm most excited about is probably using the plant itself as the sensor. So you'd have 30,000 sensors per acre per cornfield, where you were either reading the color or reading the temperature. These are depicting a ground-based infrared thermometry. I'm actually even more excited about the aerial-based, where we might be able to rather than having those sensors tied up for one field because they're mounted on the pivot, that maybe we could reduce the cost of this plant health based sensing by being able to fly over multiple fields with whatever array of package sensors that we might have available to that, and then be able to verify our ET-based schedule and or spot check for problem areas as they develop within the field. So I don't know, we just celebrated at Colby and Garden City the last few years 100 years of research. The Extension Service is here in Kansas is also had our big 150th anniversary a while back, our 100th anniversary, and anyway, we have really gone from the horse and buggy to the space age now, and I don't know how far we can go, but I think the good old days are ahead of us. Even though we do have these problems associated with declining water resources, I think we can continue to be protective, and also as we consider other policy changes where we might have more cutbacks, either physically or by policy, we can make adjustments to a great degree with our irrigation systems, and and management practices to maintain crop productivity. That's all I got.
That's all, huh? Well, thank you so much, Danny. And I think, folks on the line here, any questions about what you've heard today so far?
See, I've learned if you don't show data, you don't get questions.
So I'm seeing a couple folks from Wisconsin on the line here, and we're just getting into water quantity issues. I mean, I think we've been in for a little while now, but just, if you had advice, and there's also some folks from Michigan, which I think Michigan's a bit ahead of Wisconsin in managing groundwater and in irrigation, but what advice would you have for us, if you feel like you know enough to give us some advice on how we ought to be proceeding to make sure we are managing our water resources, our water quantity sustainably?
Well, one of the things I think I was trying to illustrate, from my perspective as an extension specialist, when I have a producer come into me and so I've got this land resource and I've got this water resource, my job is help him to use that natural resource to the best of, for their best economic benefit. When we try to minimize environmental impact and that type of thing, and kind of the philosophy of the land grant system was that if we can help producers succeed, society is benefited by that, and that concept works really well when we don't have a declining resource. And so one of the issues that if you can avoid that we self-inflicted upon ourselves here in Kansas is that we didn't fully understand how much water resource was available and how much could it supply, and so I think everybody has much better information than we had, we're talking even the 40s when this was implemented. We probably have a much better handle on what the water resources scenarios look like for our particular areas, and try to make sure that we balance those supplies against the demands. And if you but you certainly don't want to underutilize the resources, and that's so even in the southeast part of our state, we don't have groundwater supplies there available, but we have tremendous amount of surface water runoff, which then to utilize those, is there a way that we can start utilizing more irrigation reservoirs to mitigate that summertime drought that we have, that turns into be our yield limit, a yield limiter year in and year out in that part of our state.
Okay, thank you, and I'll give folks, other participants, a chance to ask questions here in the chat box if you have them, and then if not, I have another question. But okay, then so my other question is about what full allocation means for you in Kansas. So you talked about the eastern portion of the state being, I think, fully sustainably allocated, but as you indicate, there might be improvements in technology or improvements in keeping water available for crop use. How do you determine how much water is available for use in irrigation? Broadly, well, like across an area.
Right. Well, it's pretty well established. I mean, you can pretty well establish what your irrigation. I used that one slide that had the net irrigation requirement, and basically, if you think about how much we have, about everybody has good climatological data where you'll have some you'll have an average, or you can have some probability level of precipitation during a growing season. That same data you can also very accurately predict what crop water use is, and so basically your precipitation, your crop water use minus your precipitation divided by an irrigation efficiency is your net irrigation requirement, and then your gross irrigation requirement would be divided by your precipitation or your irrigation efficiency. And so and actually that kind of information is pretty widely available in the U.S. The next question, though, is that, like I said, we used to think just more or less the water balance of the we use the soil as our reservoir to hold the water till the crop uses it, and but back in the flood days we had to have extensive tillage programs to prepare the furrows and whatnot. And now that we have center pivots that allow us to use more of the low-till and no-till type systems, we actually, as we started losing irrigation capacity, we offset the loss of capacity with improvements in cultural practices, i.e., we would save 2, 3, 4 inches of water from not having to either till and or catch more off-season precip. And so you can refine your net irrigation requirement a little bit more like that. Now the harder part is probably deciding what if you're using it all depends on your state's laws too about who owns the water. We have everything from Texas with right to capture. If the water's underneath your ground, it's yours if you can capture it, versus an allocation state, appropriation state rather, like Kansas, and we have various things in degrees that will have to be factored in on how much water is available for a user to access. And then once you know how much you have available to access, you can make pretty good determinations on what crops you can irrigate and or how much land you might be able to sustainably irrigate.
Got it. Thanks. And then we have a question here from Eric Olson up in central Wisconsin. You can see that in the chat box. Some Wisconsin farmers claim that more efficient systems will reduce overall groundwater draw, but there's evidence suggesting that more efficient systems actually cause more groundwater use because farmers switch crops or bring new fields into irrigation. What advice would you give to Wisconsin educators and policymakers to address this paradox?
Well, increasing irrigation efficiency doesn't, if you're already fully irrigating, so if you're fully irrigating a crop using flood irrigation, if you go back and look at old manuals, they recommended you have 10 gallons a minute per acre available to fully irrigate a corn crop for our western Kansas conditions. It'd be slightly less as you move east or north into your area, let's say Wisconsin, where you probably have more summer precip relative to the crop water use. But if you're fully irrigating the crop and you go from a flood irrigation system to a center pivot system, you should be going from 60 to 65% efficiency to 85% at a minimum. And in that case, you could reduce, increasing efficiency would reduce your total water withdrawal from the aquifer. Now, if you're in a deficit irrigation situation where you have yield limiting water stress sometime during the season, and you increase efficiency from 60% to 80%, you may or may not save water. You would just make the water use more productive. Now, and so depending where you're starting from, irrigation efficiency may or may not help. But when we first started working on SDI systems out in western Kansas, there was actually opposition to having these systems put in, because they said, well, they'll just utilize more of the water. Well, in a state like Kansas, where you have an allocation, you can't use any more than you're allocated in the first place. And then we're also limited to the land base that we authorized originally. So if you did have the water supply available, you can't, and you can increase efficiency, you're still limited. So I don't buy that argument for our situation, but it could be true depending on your local laws and local policies regarding that. But if you're already fully irrigating, increasing irrigation efficiency should result in water savings, because if it doesn't, it means you're overwatering under the more efficient system.
So it sounds like the answer is you need an allocation. Like you said, you need an understanding of how much water is available for use, and then within that you can do more with it up to the limits of that allocation. But if you don't have an allocation limit, then you're just going to, then you don't have an allocation limit, right? And you can keep water. Yeah.
That's right. Yeah. See, in Kansas here, it's actually done on a county basis now, but originally, if you just divide our state into thirds, you could have applied to have a water right up to 24 inches in the west, 18 in the central, and 12 in the eastern part of the state, and that was supposed to represent the maximum water usage for a dry year, which was 80% chance rainfall year. 80% of the time you get that much more rainfall. And they've actually been converted to county-based now, although it has no practical effect since we're not really developing lots and lots of new water rights here. But so even when you're allocated water, that was an attempt to make sure that someone didn't hog all the available water by saying, well, they actually pumped, 1 year they could have pumped 10 acre-foot onto a field that only needed 2, and claimed that they had a water right for 10 acre-feet forever. Then that protected other future development from someone over applying, over on their application, asking for more water than what could be used beneficially. Mm-hmm. I don't know if I explained that very well or not, but I think you would, I think some kind of allocation system is appropriate for water distributions.
Dan, are you seeing Eric's other note there in the chat box about the Aquifer and Yin study?
Well, I still disagree with that. It has not. We have been in a deficit mode we were depleting the aquifer when we were extremely inefficient, and like I said, that's why even in some parts of southwest Kansas, there's the water allocation. Back in the 50s and 60s, basically we screwed up and allowed too much allocation. So yeah, more efficient systems don't prevent groundwater declines when you have grossly over-allocated the water. They don't. Increasing irrigation efficiencies improves productivity, and but until you have a fundamental cut of the total allocations, I'm saying we ought to make sure we use it efficiently until we can figure out either politically or whatever. That's the only. How do we reduce the allowable amount withdrawal? And we've been arguing about that for 40 years now. in Kansas since we realized we over allocated it.
Right. Okay, great. Any other questions or, let's see, comments from our Michigan colleagues on the line I see, or anyone else?
On the second part of that question, though, it says about shifting crop patterns. You know, in our state, we've been dominated by corn for you know, for basically 40 years now, and so I don't see that we've shifted crops. And but I would also the amount of water. I hear people tell me all the time that corn is a water you know, is a water hog. But if you look at the research data, the average corn water use in our state, in the western part, would be 22 to 24 inches, you know, ranging, you know, from low 20s to high 20s. And soybean and grain sorghum, if they're not water stressed, will be maybe an inch or two less. But if we look at the productivity of the crops, if I want to, so for 1 more inch of water, I get 2 or 3 times the productivity out of it. I don't know, I think that's a good trade-off. Plus, what's really hard for many people to recognize is that one of our best limited irrigated crops for deficit irrigation is corn. So fully irrigated corn is our first choice. Deficit irrigated corn is our second choice. When corn prices were low in the 2000s, we actually had almost 100,000 acres of cotton being grown in the southern part of the state. So farmers will shift to what farmers aren't growing corn because farmers grow corn because that's their most economical crop, whether they're fully irrigating or limited irrigating in our state. If we had a better crop, I bet they'd shift to it.
Great. Okay. Any other questions for Danny? All right. Well, thank you so much, everyone, thanks, Danny, for joining us in a great presentation that we'll have archived for future viewing, and that should be up in a week or so on northcentralwater.org. Our upcoming sessions in September, planning for the future of a watershed, lessons from Yahara 2070. This is going to be, I think, a really interesting presentation looking at scenario planning in an upper Midwestern watershed, and looking at, you know, if driving forces were to play themselves out, what might a world look like in 2070 related to water. So that should be an interesting presentation. And then in October, our topic is nutrient and watershed management in the Northern Great Plains. So thanks, everyone. Hope you can join us in future months, and have a great rest of your day.